Good morning, everyone who has already joined. I'll be waiting like a minute or so before you'll start this webinar. So if you can grab a cup of coffee and we'll start in a minute or so. Okay, let's start. So good morning, everyone. Thank you for taking the time to join this webinar. Today, I'll talk a bit about how to get the most of your out of your cloud environment. So I'll share some best practices that I and IO think will work to help you maximize your cloud environment. To start, a small bit about myself. I'm Erik Post. I'm one of the technology directors at IO. Which means that I'm responsible for deciding what kind of platforms and technology we use for our clients. Various type of clients, small to big, like PostNL in the Netherlands, Stage Entertainment, also a couple of Belgian clients. What kind of company is IO? We're a blended agency, which means that we have different expertises that we join together in our projects. So we approach almost all of our projects by putting together multidisciplinary teams with specialists from content and creation, from technology, from marketing. We do that with like 2,000 plus colleagues in 5 countries in Europe in total. And which is relevant for this webinar, we also have 3 cloud ops centers, Azure, AWS, and private cloud, in which we host our solutions and provide support and SLAs. Some practical things to keep in mind during this webinar. If you have any questions, please drop them in the chat. I'll do a Q&A at the end of the webinar. So if there's anything you want to expand upon or something that's not clear, just drop it in the chat and we'll discuss it at the end of the session. The session will be recorded, so you will get an email with a link to the recording, so you can watch it at your own time again if you want to. And if you have any other questions that you would like to discuss or just get in contact, you can do so by sending me an email, eric.post@iodigital.com. Okay, so the topic for today is, that's one slide too far. The topic for today is cloud. I think everybody got an idea of what cloud is. It's everywhere. All our solutions are built on it. You probably use it in your day-to-day work as well. But to set the stage a bit, let's discuss shortly what kind of cloud services there are. So we started way back in ancient times with mostly on-premise hardware, which means that we're physical servers in data centers or even at your own company office, which you had to manage fully yourself. Which meant a lot of work you didn't actually want to do because it didn't provide much value to your own clients. And on the other hand, it gave a lot of control on how you use that hardware and the software that runs on it. Another characteristic is that it is usually requires capital expenses, so you need to invest upfront in order to get the right hardware, to make sure you have the right capacity. And scaling is very limited. Then we made the move to infrastructure as a service. So instead of the physical hardware, the physical CPU, physical memory, we went to virtual computing. So computing resources, CPU, RAM in the cloud, accessible over the internet. Which also made the shift to a more pay-per-use model. So instead of paying upfront for resources, you pay afterwards for what you actually use. And also the shift in managing those resources, because now there's a cloud provider that manages the infrastructure part of the cloud computing. And another advantage was that it increased a lot of the flexibility in scaling on hardware level, on infra level. The next step was platform as a service, and instead of providing like CPU, RAM, or computing resources, it went more to providing a platform as a service, so a development platform where you develop your applications on and host them on a cloud platform. Again, this is a pay-per-use model mostly, so pay for what you actually use and not upfront. And the provider manages a lot of the underlying platform, usually a serverless kind of platform with functions or lambdas, depending on what actual platform you use. And it provided you with the option to make scalable application platforms instead of resources and server platforms. And the final step for now, maybe who knows what's next, is software as a service, where it's not about building your own application on a cloud platform, but using an existing application developed by others, by a SaaS provider. Well, it provides a lot of benefit in that you don't have to do the development or the maintenance yourself. But on the other hand, the cloud provider is in control, or the SaaS provider is in control over what functionality is there and what kind of features are being developed. This is usually based on a subscription model where you pay for a monthly fee for using the platform, or pay for additional resources you need. And the provider fully manages that platform. So what we see is that kind of in the last years, there is a shift, and we are calling that shifting right, where a lot of our clients started with co-location of VPS or even doing their own hardware, moving to IaaS, moving to PaaS, moving to SaaS. So in each step you make to the right, provides benefits in more scaling capabilities, but also more vendor lock-in, because you're more dependent on the features that a cloud platform offers you. But it also provides more cost flexibility and more ways to automate and repeat and make sure that the management of your platform becomes easier. And on the other hand, you see that it does increase management complexity, because especially for PaaS, there are a lot of services in cloud platforms that you can use. Depending on what service you need quite specific expertise in order to manage all that. While in the end, and the more you shift to the right, the more that complexity, the less that complexity becomes. And also the upfront investments are less, because it's more based on what you actually use, and instead of doing upfront investments and hoping that you made the right decision for the right capacity. So we see a lot of our clients shifting to the right, and some are more to the right, some are a bit less to the right. But in the end, a lot of companies are making that move in order to get the benefits that cloud native can offer you. Maybe you yourself are also shifting to the right, and you're in the cloud and everything looks good. You have a sunny landscape. But then there are some challenges that are coming around, and you see that while the cost flexibility increases, the predictability decreases. So if your product becomes successful, what will it do with the costs of all your cloud resources? And the same for compliancy and security. Compliancy is an important topic nowadays, as well as security. So how do you make sure that all the applications or your solutions that you run in the cloud are compliant with GDPR, with other compliancy regulations, and how do you make sure that your data is safe? But also your developers. So with cloud comes a lot of different services that you can use. How do you make your developers happy so that they use the right services, they use the right tools, and they are actually building value for your own clients and not getting burdened with all kind of cloud management or infrastructure management problems. And finally, nowadays there's also a lot of data that is being gathered, that is being used to make your solution more successful. But how do you use all that data? There's so much data. How do you get the right insights from it, and how do you make sure that you do that in a right way with respecting the privacy of clients? So that's why I see with our clients like 4 challenges that are occurring when shifting right. So the first one is the unpredictability of your cloud costs. So when your success of your solution grows or your business grows, your cloud costs will also grow. That that is usually accepted, but they also become much more difficult to predict because it's not very clear always what make up those costs. The second one is then all the security risk and the compliance complexity that is around, because there's so many regulations that you have to adhere to. It requires a lot of specialized knowledge in order to make sure that you actually comply with all those regulations. So that's a very complex field, and clients are struggling with how to do that in a manageable and cost-effective way. And the third one is like the developers, they need to know how to build an application. That's why the developers, but they also need to know how to run it. But they also need to make sure that they're still accelerating and that they provide the value for your customers. And the final one is that data is becoming a strategic asset. So it's very important to do your business. And as such, you should also view it as a strategic asset and make use of the data that is there. But how do you do that? How do you combine all those different sources of data? How do you do that at scale? And that's quite a complex problem. So let's dive into each of these 4 challenges and see what I think you could do to overcome those challenges. So first one, cloud cost control. Well, there's been several research reports that look at cloud costs and how much waste there is. So and one of these reports said, well, then there's like in this year already 27% of estimated cloud waste. So that's costs you make for cloud resource that you don't actually use, or they don't contribute to your business value. And while it's down from like 4 years ago, it's still quite a lot. It's over a quarter of the costs that are waste. So what can you do to make sure that waste is reduced or even eliminated? And I think that an important part of that is visibility. So while cloud cost structures are getting complicated because of the pay per use, it's difficult to predict what kind of cost you will make. It's very important to give insight in how those costs are built up. So how much traffic do you get? How much data is being transmitted? How often do your functions run? And what kind of capacity is there? So by getting those insights, you know where the waste is, and you make it visible. And the second one is to give the teams that build your solutions, give them accountability on those spends. So instead of having the team in the dark, not aware of what the solution they are building is costing, they don't have the possibility to actually optimize those costs. I think the team that is building the solution has most control over reducing the costs or making it more cost effective. So it's very important to give those teams insights in those costs, but also discuss with the teams how can we reduce the costs, or how can we be more cost efficient and make them accountable for it. So, for example, it could be part of like something like the definition of done of your sprint teams, or it could be something that is that is taken into account in a review, or those kind of things. But make them aware and accountable. And in that way, you also give them the possibility to actually optimize that cloud resource usage, and make them in control over the costs of their solutions. But it also means that you need to give them the tools and the insights to be able to do this optimizations. So what are the ways to do that? Most cloud platforms like Azure, AWS, GCP, they provide a lot of functionality in order to give those insights. They have dashboards, they have the possibilities to set budgets, to set alerts if those budgets are exceeded. You can also use tagging of resources to make sure that any costs associated with those cloud resources are linked to the right team, or to the right business unit, or to the correct so that it can be handled financially in the right way. And like I said, Azure, for example, provides a lot of functionality to customize those dashboards and to group resources in such a way that you also give teams visibility to the things they need access to, and not to all resources that are in there. And the second one is that those cloud platforms also provide a lot of APIs to extract that cost data. So in that way, you could integrate it with your financial systems. You could even create some custom dashboarding or tooling. So, for example, for our own Cloud Ops Center, we created a process that will extract all the cloud costs and integrate it with our financial system, so that all invoicing and purchasing is done automatically. So that's also an option to do. And finally, that's something that has been going on since like 1 or 2 years now, is that there's an open standard focus that and it stands for FinOps Open Cost and Usage Specification. And it's an open source standard that standardizes the way cost data is exported from cloud platforms. So it's a standardized way, independent of what cloud platform you use. And there's a lot of tooling that supports that focus standard. So especially if you're in a multi-cloud situation, you can easily collect all that cost data and process it. And all cloud platforms support this standard. So that's really something to look into. And one of the ways, for example, to make sure that you are in control of those cloud costs is by using autoscaling. And of course, autoscaling is usually used for increasing capacity. But as you see in this diagram, it's also always a kind of a battle between providing the right amount of capacity to match the load on your solutions, on your applications. And you don't want to provide too much capacity because that will cost too much, but you also don't want to provide too little capacity, because then that will impact performance and the customer experience. So usually with autoscaling, of course, you make sure that capacity increases as load increases, but it's also a very good way to scale back down to zero. So when there's almost no traffic, or when there, for example, you have a test environment or acceptance test environment, when it's not being used, just scale it down. Make sure that it doesn't incur any costs, and when it's needed again, it scales up automatically. And if you use the right services from the cloud platforms, it's actually quite easy to do. And it can help save a lot of unnecessary cloud spends. And there's also, of course, the options like the discount options, reserved instances where you pay for 1 or 2 or 3 years to get a discount rate on certain resources. But of course, the the limits that you are reserving that instance for a fixed time, so it decreases the flexibility a bit. As for security and compliance, of course, it's nowadays, there's so many compliance regulations, of course, a bit depending on what kind of domain you are. Yes, but everybody knows GDPR. ISO 27001 is also a very well-known one. NIS2 is I think one that is quite important this year. So yeah, depending on in what domain you are, there's just a lot of regulations to deal with and to make sure that you're compliant and that you do everything in the right way. And on top of that, there's of course also a lot of security threats. So also one report that mentioned that a lot of CIOs are concerned for mostly insider threats, ransomware, phishing, but also data breaches. That means that there's a lot of care needs to be taken in order to make your solutions secure and compliant. And of course, the cloud platforms help you with that, but they don't take it out of your hands completely. For example, AWS, they clearly specify their shared responsibility model. So they clearly define what kinds of the stack are managed by AWS, by Amazon, and what guarantees you can get from them. So they make sure that their hardware, their regions, availability zones, etc., and the services that are offered on top of that they are compliant, that they are secure, and depending on what kind of services you need, it can differ the kind of compliance there is, but at least they make sure that that part of the stack is okay. But then what you build on top of it yourself, you're the one that is responsible for making sure that that part is secure and compliant. So any configuration of the resources, any applications you build on it, any access management, you as a cloud service user need to make sure that that's compliant and that it's secure. And the same applies for AI usage. So Microsoft have really defined clearly and also shared responsibility model for how do we deal with AI services. So how do we make sure that the model is safe, that your data is handled in the right way? But again, here also, it's not only the cloud provider that is responsible for that, but also the ones using those services need to take care of that. So one way to do that is to use the policy frameworks that cloud platforms provide. So and using those policies, you can either monitor how resources are configured. So you can make sure that access is set up in the right way, or that network security is configured in the right way. And not only can they monitor that, so they can give a notification if something is not compliant to those policies, and they can even enforce it. So they can prevent creation of resources that do not conform to the policies, or they can block those resources if they are not compliant. This is a very strong mechanism, very strong tool to make sure that your cloud usage is done in the right way. And the great thing is that Microsoft, but also Amazon, they offer like kind of starter kits or frameworks that already contain the controls for a lot of certifications or regulations that are in there. So, for example, for NIS2, there's already a kind of base setup for the policies. They list all the controls in the documentation. They specify what needs to be done in order to implement those controls. But they also provide the tooling and the sources, so to say, to implement those policies. So that means that you don't have to do it all yourself. There's a lot of material that you can already use to to set up your own policy framework and tailor it to your own needs. And the great cloud providers, they also have what they call the cloud adoption frameworks, which are guidelines and standards and best practices on how to set up your cloud environment. So if you move to the cloud, they specify how do you set up your governance model, how do you set up your networking topology, how do you apply the policy frameworks. All those kind of elements are in there. And they really document that very well, and it's a really great starter to introduce that into your own environment and to make sure that your cloud adoption is successful and that you're getting helpful tools in order to achieve that. And the final thing around security is that, of course, there are a lot of services that are available, ranging from networking security. So Azure has the private endpoints, which make sure that all communication between resources is over private networking links and doesn't go outside to the internet. There's web application firewalls that make sure that your web application are secure against cyber threats. There are ways to store your data security and to manage to do the encryption of the data and to make sure that access to data is checked and that the governance is verified. They provide a lot of identity and access management solutions, not only for your own company users but also for your customers. So SIAM, and they provide a lot of tools to detect and to act upon anomalies. So if there are attempts to log into the system and they fail often, then such kind of behavior is flagged and it can be acted upon in order to make sure that your solution is still safe. But the main thing of these things is that, in my opinion, security is clearly one of the major parts of the business model of cloud providers, because most of those services, they will cost you a lot of money. They ask the premium fee for it. So you can start small, but if you really want to use those security features, it can add up pretty quickly. So it's very important to carefully weigh the costs of such a solution to what will it actually bring me, because maybe you don't need the top of the bill endpoint protection because the effect of the risk is not that big, or the potential effect. So it's very important to carefully weigh that and to make sure that you decide upon fitting measures and not just check all the boxes and think, oh well, I'm secure right now. And the third one is self-serving developers. So what we see is that the cloud platform or any development platform, the more flexibility it provides you, the better the team is able to execute, to deliver, and to develop software in an efficient and in a way that provides value to your clients, to your customers. But there's also a limit to that. If the platform provides too much flexibility, or there are not enough guide rails or guidelines to help the developers to efficiently use the platform, then the ability to execute decreases. So the challenge here is to find the right way of the right balance between providing flexibility in your cloud platform, but also providing enough guardrails and guidelines to make sure that they don't make a mess of it, so to say. So there, what we see is really the trend for platform engineering. So what we see is that there are dedicated teams that manage the digital platform. So they manage all the use of cloud services. They manage kind of the standard ways to build solutions. They handle the continuous integration, continuous delivery pipelines. They provide the tooling in order to monitor and to provide the support on your applications. And those services they provide, they are used by the product and service teams. So they don't need to deal with all the intricacies of the cloud platform they're building upon. So that is part of the platform team. So in kind of way, this is an evolution of the DevOps model where the operation part is integrated in the development team. So you build it, you run it, you own it kind of mindset. But we see in a lot, especially at the large companies, that are dedicated platform teams that make sure that the cloud platform is used in the right way. And usually they provide kind of like 4 services to the product and services team. So they make sure that the knowledge is managed in the right way, because you just need to know a lot of stuff and to know what are the best practices, what are the do's and don'ts. So, and the platform team manages that knowledge. And they also provide the guardrails. So they basically set the limits on what can be used in the platform and how it should be used. But they also provide the flexibility to move between those guardrails. So it's not the challenge is to make it flexible enough. So don't make it closed so that there's no way to experiment or to innovate or to try new services. But and on the other hand, make sure that they don't fall over the edge if they try other things. So that's why we call it guardrails. And they're also responsible for providing the tooling. So think like the CI/CD, continuous integration, continuous development tooling, but also the monitoring of applications, incident management, all kinds of tooling that is needed to deploy and run the solutions. And what I think is that the platform team also has an important role in providing that cost awareness. So as I mentioned earlier, you need to give teams the visibility on the costs of their cloud solutions, but they need a way to get that visibility and get those insights. And that's typically something the platform team can provide them by setting up the dashboards, by providing them exports if needed, by making sure that the right resources are visible to the teams, and to foster the discussion on how costs can be decreased and how cost efficiency can be increased. To dive a bit more into the knowledge, so things that you can do are just set up the best practices, document them, and make sure that they are also shared with the development team. So it's more about getting the discussion going and talking with each other over what those best practices are, than just defining them and dropping them somewhere and then hoping that the other teams will pick them up. So it's really in the conversation that is important. And the same applies to documentation. So it's important to document the rationale for certain decisions, to define architecture decision records. So to make sure that why things are done in a certain way is clear, and not so that everybody understands why that is the way to do it. You also see that, especially at larger clients where they have a lot of API integrations for external parties, that there's an important role for developer portals. So those are the information sources on how to use an API. Give examples on how you should use it to provide support on how to use the APIs. And if you're looking at the more like an internal API kind of setup, then something like service discovery is important. So what APIs are available and how can I access them, and how do I know what kind of API I need in order to provide my business functionality. And as I mentioned just now, the active knowledge transfer is very important. So set up lunch and learn, set up hackathons, set up workshops. So interact with each other to ingest and apply all that knowledge that's available. And as for tooling, one I think important element in there is using infrastructure as code. So cloud platforms like Amazon and Azure, they make it very easy to just go into the portal, click some checkboxes, and do everything by hand, and setting it up by just clicking all the resources you need. But that's not really manageable, because it's not repeatable. It's very error prone. It makes it difficult to take the all the guidelines and all the principles into consideration. So that's why you should use infrastructure as code. So that means that you describe your state of your infrastructure in source codes, and Terraform is one example. Bicep for Azure, CloudFormation for AWS. So there are a lot of tools that allow you to describe the way your infrastructure should look like, and then integrate it into your CI/CD pipeline, so that if there's any change to your cloud environment, that it's deployed automatically as part of your build cycle, your deploy cycle, and that there's basically no human interaction in order to configure things in the right way. And if you combine that with starter kits that are out there, for example, Azure provides Terraform modules and Bicep modules that set up resources in a way that Microsoft thinks is recommended, and they usually have it in the right way. So you can use that as a starter to build your own solutions upon, so you don't have to start from scratch. And if you link that with tools for monitoring and insights, then you give the product and feature teams the necessary means to be able to develop and run their applications. Just a short example from how Microsoft sees this in Azure. So at the bottom in the orange area, you see like the kind of services that the developer platform provides, so like CI/CD actions, the API catalog, so the service discovery, as I mentioned, and they provide an API on top of all those services that can be used by the teams that are building the features and building the applications. So just an example on how Azure does it, but AWS has something similar, and GCP probably as well. Then the final one, data. Of course, in today's world, AI, it's very important to have a good data strategy, because data strategy is crucial to getting generative AI successes. So the success of your AI use case depends on the quality and availability of your data. So that's a really important topic that a lot of our clients are struggling with. So how do you deal with all those collecting all the data, managing all that data, bringing it together, getting the insights on it, but also doing that in a secure and compliant way, because privacy is important. The end users want to know what is being done with the data, how it's being used. So if you provide these kind of solutions, you need to take into account how that data is managed and how the privacy of your users is managed. And what you see is that cloud platforms, of course, provide a lot of services to do just that. And where in the past it was more like, we provide the databases, we provide the data warehouse functionality. It's now the trend is to go more to fabric kind of solutions, where you basically shift to the serverless model, but for data processing. So you don't need to set up databases with certain capacities that you pay a fixed fee for. No, you can do the data processing in a serverless way. No need for allocating resources beforehand. That's all managed by the platform. Some examples. So Microsoft provides Fabric, which is basically a kind of combination of different technologies, services that they already offer. So like the storage blobs, the data factory that can be used to define ETL processes and so that kind of things. AWS has the Glue, where you can combine all kinds of data sources. And on top of that, you build your Gen AI processing. So you can use Azure OpenAI services for that, or you can use AWS Bedrock. And on top of that, you build your Gen AI use cases. But across all those layers, the compliance and security is really important. So, and also there, the cloud providers provide a lot of services that help you to give insight in what data is there, how is it being accessed, who can access what, how is the governance management managed. So it's really good to look into that and to invest in that kind of technology. But on the other hand, it's quite complex. It's a large field. It really needs dedicated specialists that are really into the data engineering, the data integration. So that makes it a complex field. And also here, there's the link with the cost control because not all data is handled in the same way. There are different types of data. For example, if you have time series data like measurements of some kind of sensor, you would want to store that and process that in a different way than just having unstructured data or structured transaction data. So you really need to carefully consider what kind of service you use and what kind of service characteristics fit to that use case. And the same applies to the access pattern. So if you have data that's accessed really frequent, that will require different cloud service than just having data that is archived and accessed very infrequently, but could be a lot of data. So you also need to select the appropriate data access tier in order to use it in a cost-efficient way. So in general, you see that as the frequency of access decreases, your storage cost will usually decrease. So it becomes cheaper to store more data. But your transaction cost, so the cost of accessing the data, that will increase. And that's something you really need to take into account when designing your solutions and selecting the right cloud service to match that solution. So to summarize, what do I think are some best practices to manage those challenges that we mentioned that I mentioned earlier. So the first one is to make the cost predictable, so and also controllable. So define a cost control strategy. So how do you deal with costs? Give the teams the insights to and the visibility on those costs. So make them part of the solution in order to get more cost efficient. And provide them with the right tooling to do that. That will definitely help in making those costs more predictable and reducing the waste that is there. And the second one is to use those cloud security services, because if you want to do that yourself, build those kind of solutions yourself, that is no way that you can manage that. Carefully choose what kind of security services you need to use and that match the risk assessment of your cyber security risks or your data breach risk. And if you don't do that, you run the risk of spending way more than you actually need to spend. And also use then the policies to set up the guardrails and the guardrails to make sure that the development teams are complying with the regulations that are relevant for your domain. The third one is to support that self-serving developer. So invest in knowledge management, make sure that your best practices, that your rationale of why you do things in a certain way are known and are shared with the teams, and adopt the infrastructure as code approach to make sure that setting up new resources becomes very efficient, less risk of errors, and a lot of benefits in doing that. And the final one is approach data as a strategic asset. So don't see it as a byproduct of all your transactions or all your customer interactions, but really use it as a strategic asset that you can use to create value. But also make sure that you use the right services to support the data management, because that's one of the complexities that's in there. So now you might be asking the title of this webinar was 7 best practices, but now I only got 4. So what's the deal with that? Well, if you want to know the other 3, just check out the white paper that I wrote together with my colleague Fizo, and there you will find the other 3. And here's the link. So the slides will be shared, so you can access the white paper. Okay, that's it for now. Thanks for joining. If there are any questions, feel free to ask them in the chat. If you want to connect, or want to discuss, or want to approach me personally to discuss some things, you're welcome. Send me an email or connect to me on LinkedIn. So, well, let's take a couple of minutes to see if there are questions, and feel free to ask. No questions. Totally fine. And thanks for joining. And maybe see you the next time. And have a nice day.